same time whether just it is ester or the electronics of that protecting group is also helping to give the selective product. So before coming to this work, in from the same group in their previous study, they have taken that glucose thioglycoside, and in that they have changed the various protecting group at C6 position, C6 hydroxyl group. They have used various protecting group starting from estate to pulyl and then or paramethoxybenzoate from paranitrobenzoate. So basically they have taken just simple acetate like, and then later they have various electron rich benzoate donors, and then at last they have used this electron deficient benzoate donors. So what they have observed in case of glucose, when and they have used this acceptor L-menthanol, and they are activating using NIS triplic acid 10 mole %, and temperature they are keeping from -78 degrees Celsius to 0 degrees Celsius. So in that case, they are observing the moment this R group, they are using very much disarmed, not disarmed, sorry, electron deficient benzoate donors, acyl donors. In that case, alpha selectivity they are getting maximum. So this comes from their previous report. But similar report came from the G.J. Boone's group. They have done on the galactose in case of glucose. Instead of glucose, they have done on galactose, and they have changed the protecting group in the C4 position. Similar changes they have done. They have taken uh, uh, benzyl protecting group that shows alpha to beta selectivity very less, and then the moment they are going towards the electron rich benzoate donor, they have got very much good alpha selectivity. So what they have found that these two results are very contradictory. Like this report from Jensen group, in case of glucose they have got alpha selectivity with the more electron deficient benzoate donors, but in case of this Boone's report, what they have observed when they are changing this using this electron rich benzoate donors at C4 position, so they are getting better alpha selectivity. So what they thought, to check the role of how this distal acyl groups are affecting the selectivity of reaction. So there could be many possibility. There is a possibility some intermediate may be forming, or whether just there is a possibility just the electronics are playing the role. So to solve that, they started their study on galactose to check that whether whatever they have done earlier on the glucose, same thing is applicable on galactose or not. So first they have taken this thioglycoside containing this various protecting group at C6 position, and they have done similarly as they have done in glucose. So they have started from just completely OBN protected thioglycoside to changing to OBZ, and then they have observed there is not much change in the there is no change in the selectivity what they are obtaining. But then when they are using this similarly when they have used electron rich benzoate donor or electron deficient benzoate donor, again there is no change in the selectivity. So to check the role of whether, because in the case of this Boones, they have used some different kind of acceptor, sugar acceptor, that is chiral. So to check that whether any role of chirality or some acceptor role is there or not. So the moment they are taking different acceptor, 2-methoxyethanol, keeping in one case OBN C6 protected and in one case disarmed, sorry, electron deficient benzoate protected protecting group. Again, in both cases, they are getting almost similar alpha to beta selectivity. So from here, they have concluded that in case of galactose donor also, C6 protecting group has no role in the controlling from the remote position of alpha beta selectivity. So next what they have done, so again they have claimed that they have observed from the literature report when various reports are there when people are using this modified trifluoroestamidate donor. In that case, people are getting some different selectivity. So what they have planned, they have used the same protecting group at C6 position also, and they have tried to check whether this can have some role. So what they have done, they have taken this donor 38. In one case, they are keeping this same protecting group at C6 position also. So they have got good alpha to beta selectivity. And again, so here they are changing some this sorry. So in one case they are keeping this OBN, and in one case they are keeping they are changing the solvent also. So when they are keeping this protecting group same and they are varying the solvent, they have got uh, different alpha to beta selectivity. So when there is the PT, this modified trifluoroestamidate protecting group at C6 position, and in all these cases they are using this sugar acceptor. So they are getting better alpha to beta selectivity ratio. But so similarly they have tried. So they thought there could be the role of this PTFAI, but when they have used this just benzyl protected donor at C6 position, then also they are getting good, although it is not as good as this ratio, but they are getting better alpha selectivity in the, although if just OBN is there. So what they have claimed that, so to check the role of, again, since there here they are using this sugar acceptor. So this is already known in the literature. The solvent and nucleophilicity of acceptors are known to affect the alpha beta selectivity ratio. To check that, again they have changed this acceptor from this sugar to L-menthanol. And in that case, again in both of the cases they have observed that there is no alpha beta selectivity, very bad. They are not getting good. So what they have claimed that in these cases, whatever yield they are getting, that could be probably just because of this acceptor, or there could be the some role of solvent. But majorly, they have proposed that it is mostly this selectivity they are getting because of this acceptor. There is no role of the donor or the this remote protecting group. So again, in nest control, what they have planned to do that. So they have taken this thioglycoside, and then this time in galactose, since by now they have established that C6 changing in the C6 protecting group from OBN to H state or any electron deficient protecting group is not doing much in the alpha to beta selectivity. So they are moving to C4 and C3 protecting group. So they have made various this donor, and then they are using various cases, and they have shown that when they are using this completely OBN protected donor, like all are OBN, in that case they are getting not very good alpha selective product. The moment they are increasing this electron rich OBJ donor, when they are using at C3 position, again it is not good. So the moment they are moving further, so they have found that when they are using this para-nitrobenzoate protecting group at the C4 position, in that case they have got little better alpha selectivity. And when they are keeping this both paramethoxybenzoate donor at C3 and C4, still they are getting better alpha to selectivity ratio. And when there is a 1 there also, but it was not as much as this one. So when they are using C3 and C4, both benzoate and others are OBN protected, in that case they are getting better than this methoxybenzoate donor. So the moment they are putting the more electron deficient donors, so that cases the alpha selectivity is increasing. So in last they have kept the para-nitrobenzoate group at the C3 and C4 both places, and they have found that in that case they have got the maximum alpha to beta selectivity. But the problem in this experiment is that, like here they are using this NIS triflic acid from -78 to 0 degrees Celsius. So in all this experiment, in this, the moment this electron deficient protecting group they are using, so all these stretch cases, they have observed that reaction is not getting completed at the same temperature and same equivalent of NIS. So in these cases, they have to use two equivalent of NIS, and again they have to increase the temperature also -70 to -78 to -30 degrees Celsius. Then only reaction is getting completed. So it was found, they found that this is not good for the comparing the results for all the cases. So what they have thought, to instead of taking thiophenyl glycoside donors, they have taken this thiohexyl donor, which will be which is known to be more reactive, so that can be activated easily. So in that case, they have observed that in all of the cases, reaction is getting completed at the similar activation condition and similar time. So in that case, again, they have used various similar protecting group of donors. So when they are moving from completely OBN protected donor to giving this para-nitrobenzoate protecting group at C6, C4 and C3 position. So in that case, again, they are observing the maximum alpha to beta selectivity. And to check that, they have again protected this C6 position also. So they have found that keeping this when they are keeping the C4 protected and one of the either C6 and either C3 para-nitrobenzoate protecting group, in both of the cases, similar selectivity is almost same. So there is a maximum role from the C4 position is coming. So whenever there is a most electron deficient benzoate protecting group is there at C4 position, that is giving the maximum alpha to beta selectivity ratio. So having done this, so by now they have established their own result, whatever they have previously done in the case of glucose. Glucose, it was getting controlled from the C6 position, but same is not possible in the case of galactose donor. So they have shown that in case of galactose, C4 protecting group, if they will keep the electron deficient benzoate or acyl donor in the C6 position, that is giving better alpha to beta selectivity ratio. So for mechanism, what they have proposed that it could be, they are not sure, like whether a rule of some kind of like dioxyuranium intermediate is there or just electronics is there. For time being, they just believe that it is mostly because of the electronics, not because of the any cyclic intermediate. Like as we are knowing, in some cases like benzoate, how it will participate. If, as we know, in case of C2, if some ester is there, it will form some dioxyuranium ion intermediate, and that, so similarly there are reports from C3 and C4 position also, those kind of possibility is there, but from this group they haven't done those kind of study. But for time being, they are suggesting that since in different sugar it is showing different patterns, so it could be mostly because of the electronics. So to show the application what they have just proposed, so what they have done, they have taken this, as we know in case of GB3 antigen, this one galactose moiety is connected to another galactose via alpha linkage, alpha 1,4 linkage. So since they have showed that in this particular donor, they will get better alpha selective products. So they have done this, they have used this donor and then acceptor 70, and they have found that they are getting alpha to beta ratio as 30:1. So to show the application, they have shown this. And further, at last, which I have just mentioned, so they are suggesting based on this report, there is a old report from their Vither group and co-worker. They have shown that in case of deprotected sugar, the moment this fluoro group will, in case of glucose, if it is getting from uh, um, C2, C4, C3 or C6 protecting group, in that case, if you'll see C6 changing at C6 position, keeping fluorine group at C6 position in that case hydrolysis is like rate of hydrolysis is maximum. And while in case of galactose, if the electron deficient group is at C4 position, in that case rate of hydrolysis is maximum. That's so the similar trend like what they have got earlier. So in case of galactose, C4 keeping electron deficient protecting group at C4 position is having more control than the C6 position, where that is reverse in the case of glucose. So uh, they are concluding this work parallel saying that the comparing with this previous report, saying that since although it is in deprotected sugar, the similar trend is getting followed in the protected sugars. Thank you.
Nice presentation.
Thank you.
Can you go to slide that glycosyl donor? Okay, so exactly what electronics is happening? That's why they are getting the alpha major, not the beta one. Exactly what is happening in the electronics, like electron withdrawing group they are using.
Yes, so that is a good question. So in this paper also they are not sure. They are writing that clearly. They are not sure exactly what is happening, but they are thinking that as we know that like by changing the electronics, somehow the possible intermediates form, like as we know, right, SN2 or SN2 prime, carbocation is forming or some in between
Yes.
intermediate is forming. So they are suggesting at that level some change is happening. So that they are not able to establish it yet. They are working on that. So, but they are telling in the abstract part itself or in beginning only. So there is a possibility that distal ester, whatever distal ester we are using, distal means that remote ester we are using, the electronics of that may involve in shifting the mechanistic pathway. Like it can go from SN2 to SN1 or SN1 to SN2 like that. Some shift is there. So there is no clear cut evidence for that. For time being, they are presenting the result.
So is it like that maybe C3 or C4 they are pressing electron withdrawing group. So the
Yes.
carbonium ion making more electron deficient, so more reactive. So now glycosyl donor is leaving from beta side. So the whatever the acceptor is there that have only one A that will come fast because it is more reactive. So it will come from alpha very fastly and alpha is getting more like electronics point of view something.
Yes, exactly. So they are trying to say like that. Yes, same thing they have mentioned. So they are believing that the moment reactivity is increasing, so and that reactivity is getting controlled by this electronics of the protecting group at the particular position. Like in case of galactose, they have observed, glucose, they have observed it is getting more controlled by the C6 position, but in case of galactose, it is more from the C4 position.
In galactose case, there is also NGP, like not galactose. I am telling about general sugar, like C6 something ester is there, so it will protecting from above side, from beta side, something like this is there. I don't know exactly, but
I think so. There are various reports are there. Too much reports are there. So, but all those things are very like narrow. This is also they are showing for the particular one sugar. In previous paper, they have shown for the glucose. There is no general thing is there. As we know for the C2, if you will keep C2 state group, in
hmm.
99% chance you will get the selectivity. There is no conflict is there, but from other cases there it is getting like sugar to sugar difference is there. So if you'll
Hmm.
show, I am pretty much sure there are reports are there which will show from the C4 position also they will form this dioxylamine ion intermediate and it will directly give the alpha or beta product. So those kind of reports are there, but
Okay.
I don't know exactly how to generalize. Like in this particular paper or from this group, they have done they published too many paper based on the similar to this kind of thing in various sugar. So in this particular kind of setup, that selectivity is there.
Hmm. And they have not tried for C3 and C6, like C4 they will keep the benzyl, and C3 and C6 they have not tried, I think, those positions, two positions.
I think they might have tried, because here when they are keeping this, they have shown that. But whenever they are keeping C3 and C6, always there is a C4 protected group is there. So I haven't checked the supporting information. I think they might have tried. That result might not be good enough to show. There may not be the desired selectivity may not be there.
Yeah. Okay. Thank you.
Yeah, nice presentation. Uh,
Thank you.
go to the previous slide that we are discussing right now. Previous. Huh. In this slide, like in in a in this table one, there is a role of electron donating group and withdrawing group. But
Yes.
in this B, there is 19 and this 21. This paranitro and paramethoxy, both are
Yes.
giving like means in this there is no role of this electronic effect.
No, no,
Why?
it is there. It is there. Actually, these two reports are coming from the two different group. So whatever A, it is coming from Jensen group, which paper I am presenting now, and this is coming from the G.J. Bones group. So what this Jensen group is claiming that whatever selectivity they have got in the case of glucose, that is completely opposite trend from this report, but they have done on the galactose. So in case of this report, if you'll see, the more electron rich benzoate group is giving more alpha selective product comparison to this nitro or trifluoro ethyl protecting group, which is more electron deficient. So to verify this thing, to check this thing whether similar report is coming in galactose or not, this group has done. So these things, if you'll see this, they are trying on galactose to prove that point. But at last they are concluding that whatever result they are getting, it is not coming along this line, whatever G.J. Bones group has reported. They are getting similar trend in case of galactose also, but just position is changing from C6 to C4. You got my point?
Yeah. But to why like in Galactose they didn't try for C6?
No, no, they have tried. They have tried, and they are showing that C6 has no role. Like here, only C6 position they are changing. OBN, OBZ, OME Paranitro BZ. And in
Okay.
that case, they have shown that selectivity, there is no like significant change in the alpha beta selectivity. So first they have done at C6 position. They found that there is no selectivity in case of galactose changing the protecting group at the C6 position. Then they move to different protecting group. Then there also they have shown that keeping different protecting group is also not helping much. So later again they move to this protecting group at the C3, C4 position. So they have found that the moment they are keeping the C4 disarmed donor, immediately they are getting better alpha to beta selectivity ratio. But
Okay.
they are mentioning that it is not falling along the this report. Like this is, so there must be, there may be, so to resolve that issue, they have used this thing, L-methanol acceptor. So indirectly, this paper is claiming that whatever this Boons group has got the result, there is a possibility of this acceptor has some role, because of this acceptor they have used, that is playing more role towards the selectivity whatever they have got.
Okay.
Since they cannot comment on the others result, so they have tried to give all the possible control experiment from their lab, and it is following along their studies. So similar studies they have done in different sugar, like one glucose is there, other reports are also there. So for them they are getting consistently this kind of selectivity when they are putting the electron deficient groups.
Okay. Thank you.
Good presentation, Veya.
Thank you.
My general question is that in this case we are particular selectively first we need protect this protecting group. So
Yes,
why we are using this compared to catalytic method for selectivity of alpha and beta?
that is a good question. You can use catalytic method since, as we know that in catalysis method also there is not very much, as I told initially only. Like to get 1,2 trans product, we have very much established donor or protecting group methodology. The moment
Hmm.
you will keep acyl group at C2 position, you will definitely get the 1,2 cis product. But whatever reports are there, as you are mentioning, catalytic method or some another donor itself will give the alpha selective product. Those things are not very much broad scope, or that may not be applicable in every places. That's why this problem is still open to study. So they have just shown the one way how they can tackle this problem. Still, this solution is also not very much broadly applicable, but up to certain extent, it will be able to solve that problem. So that's
O-
why. I think
Okay,
that's how we work. So it's like until unless we'll get the universal solution, we'll be keep working on from different perspective.
okay. Thank you, Veya.
Hello,
Yes,
nice presentation. My question is, since you are talking about the electronic effect or stereo effect,
yes,
whenever we see this distal participation of the protecting group, we always think about the ester like BZ.
yes,
So what I strongly feel like that electronics also there, but major it's a steric. Like if you see them also, they have tried just with the BZ protecting group. If that is
yes.
just electronics, they could have tried with the different substitution on BN group also.
That possibility is there. So they are also not ruling out, but
Hmm.
still they are more inclined towards the
Hmm.
electronic part based on the result, and that this weather report, whatever this already previous reports are there from Sri Sugar. So they are believing that. So they are also in beginning itself, they are claiming that they are not very sure how exactly it is happening. So they are saying that probably it could be both. It will be
Hmm.
both. I mean, so electronics and obviously, as we know, this means remote
Steric type.
direct
Uh,
hysteric or direct group participation will be there. So they are not ruling out anything directly, but if you'll read this writing what they have written, they are means they are more inclined towards the electronics thing, but they are
that.
not strongly forcing it out because they are not sure. Still, I think they are collecting the evidences more.
Along with that, what I is one of the other point is like with BN, it will just produce the electronic effect, not the steric effect. With the BZ, it might be both electronic and steric. So if you change substitution, whatever the changes they get, that will be more considerable compared to the BN.
Yes,
Like
I think so. I also
so,
think so that
finally they're trying to show the effect, right? So if they get the difference in the effect more, there's more difference in the effect, so easy to compare. That's one of the reason might be.
yes, and I think this is a kind of borderline result. You cannot tell
True,
very much
true, true, true.
distinctly, so it is
Uh,
difficult to compare also. That's why I think
uh,
to publish, they have done lot of this substrate scope just to show that, because already Boon's report is coming against them.
okay,
So to prove that, they have done lot of things. I think one more paper recently they have published.
okay.
So
So,
so for them it is that they are working on this similar problem from I think around 10 year or so. So
okay.
they are able to do that. But
Mm-hmm.
these kind of results are not very much distinctive. So we cannot
True,
make
true,
out
true.
lot of it. But if
Uh,
direct some application is there, definitely we can use similar
uh,
sort of predicting group.
ultimately, as you said, these borderline things are always the field of research. Like if you see alpha, beta,
Yes,
also, this is also like for what is that C to non-participating group, that is the borderline result only. So that's why all these
yes,
things are there.
yes. It is like a reduced selectivity people are doing, right? So there, if
Uh,
you'll see lot of reports, means enormous reports are there, but
mm,
still we will use old methods only. So it is similar to that.
true, true.
Like in this particular case, still I feel tuning the acceptor is very easy. So you take
Uh,
very less nucleophilic acceptor, like one paper I presented long back, right? Whirlpool paper, that erosion of stereo selectivity.
oh,
So the
okay, long
moment
back.
will increase the nucleophilicity. So
True. No, I
decreasing the
remember.
electrophilicity, nucleophilicity itself will give the this kind of
Yeah.
alpha selective product.
So that's why I think that is the one of the reason majority of the carbohydrate research labs are surviving this alpha beta selectivity.
Yes, and since in this particular case they have used this different menthol acceptor, but the moment we'll go to sugar acceptor as this Boons group has done, automatically this nucleophilicity is very less than the other
Oh,
acceptors.
true.
So that
What is
also
the
go
reason
there.
you to use this menthol?
So they have just to nullify that, like sugar, it may have less nucleophilicity,
Nucleophilicity.
that itself can give selectivity because those things are very much known in the literature. That's why they have used this acceptor as a to prove this concept. That's all. This is
Okay.
happening from the protecting group control, not the acceptor thing. So
Okay.
this is also they have found after it is kind of control only
Mm,
because many reports are there, as I am saying that many reports are there based on the nucleophilicity of acceptor. So
okay.
that's why they are not using sugar acceptor because in sugar
Accepted.
definitely that difference is there.
True.
And same time they are saying about chirality also. I don't know exactly how chirality is affecting the selectivity and all. But
Okay.
to show the role of chirality, they have used this 2-methoxyethanol in place of L-menthanol.
So in that case, also they are getting little less selectivity, right?
Yes. Less means they are comparing these two. So from Obion to paranitrobenzoate, they are getting same selectivity.
Uh,
In this case of menthol also, when they are going from Obion to either this nitro, either electron rich uh, paramethoxybenzoate, in both cases they are getting almost same selectivity. So they are saying
but
that
if you
there
see
is,
the entry 1 and 5, with the same
yes,
protecting group having just a different acceptor, it is
in
having
that.
the
Uh,
substantial difference in the
Ye-
selectivity.
Yes, so that is definitely because of uh,
Acceptor.
acceptor that is means
Mm,
methanol is more,
mm,
maybe probably it will be less nucleophilic than 2-methoxyethanol.
mm.
So that's why
Obviously, they
it
have
is.
to still have to do a lot of
uh,
studies to come for a general conclusion. It
yes.
is. um,
So I think they are doing. I haven't followed their too much of paper, but they have enough paper. In GOC itself,
Okay.
they have I think around 10 papers.
10 papers. Okay. Thank you.
Nice presentation, Deepak. So, like starting with the modification of the benzoate group at the electron donating and electron withdrawing groups. In case of GJ Bunch and this case, JJ Boons, in case of electron donating, they were getting more alpha, but they were getting more in case of electron withdrawing groups. It's like
Yes,
contradicting,
reverse.
right? Even
Yes,
though,
yes. Yes, they are starting from there itself, mentioning that since this Bunch group has got contradictory result, so
Mhm.
to check that only they have published this paper on galactose. Otherwise, they have published this paper on glucose donor. That is,
Uh-huh.
I think, 2 3 year back. And once this Bunch group has published on galactose donor. So to verify that whether this result has some problem or protecting group has some problem, to show that they have used their own set of tools like this their own protecting group and all on the galactose, and that same thing they have tried to repeat whatever this Boons group has got, but in that process they have got their similar result what they are getting earlier, just this positions and all is changing. So they have tried, they have mentioned that they have tried their best. All these results, whatever they are showing, that they are saying all the experiment they have done in triplicates. Like they have repeated, they have taken the average and they have done various statistical things also. And they are getting this result, which is still contradicting the Boon's result.
Whatever previous table you showed, in that case, I think there is no role of electron withdrawing and electron donating group. Like each case, BZ and methoxy and the nitro is
so
all
they,
or that
yes,
similar.
yes. So they are starting from C6 position, because in case of glucose, they got this. In case of glucose, they got, after changing the C6 protecting group, they got the result saying that when they are putting this para-nitro group at C6 position, they got maximum alpha to beta ratio. But same thing is not happening in case of galactose.
Galactose.
So in galactose C6, so this table shows that in galactose C6 has no role. So they are moving to
C4.
different of C4. So before going to C4, they are trying to show the role of different this protecting group also other than BZ, because they have cited two reports saying that this PTFAI group has some role. It is known to show some role, but that is also not showing much difference. So again they move to C4. So in C4 what they found, that in C4 the moment they are going to this more electron deficient donor, the reactivity itself of the donor is reducing too much. So they have to increase amount of NIS and temperature. So to uh, to bring the results at the comparable level, they have changed this thiophenyl to thioacyl, and in that case, they are getting this result, which is showing that this para-nitro-benzoate group has role, and it is showing the alpha selectivity
Maximum.
more, which is again still it is coming opposite to the Boon's report. So whole this
You
paper,
discuss somewhere. Huh? Yes, yes.
so whole paper is amongst around that Boon's report only. So since they are working from long time, so they may not be able to accept his result, but I think they cannot do about anything about Boon. So they have tried to show the all controls and all, saying that still they are getting alpha selectivity with the electron deficient benzoate donors only.
They've also discussed about the solvent roles, na?
Yes, so that is again to show that indirectly this is coming towards the Boon's work only. So in Boon's case, if we'll see carefully, as we already know, the this sugar acceptor and solvent has role of the selectivity.
Yes.
Like they have used some dioxane and toluene. So in this paper, they haven't used the same solvent. They are using normal their own diethyl
DCM.
DCM
Ether.
only, but they have added this ether,
Diethyl ether.
saying that as we know, like DCM we know as a non-participating solvent. So they have
Yes.
added participating solvent. In that case, they are getting better alpha selectivity than the case of DCM. So in both cases, if you'll see, the moment they are adding this diethyl ether, little better selectivity is there. So since they haven't used it, to show that if you'll remove all the controlling factor will control from just the protecting group, so that itself is able to control.
Yes.
Means it is a proof of concept that uh, this protecting group has role. So whether it is
Yes.
controlling via electronics or this means direct participation, that they are not very sure about, but it is very much sure that that protecting group is affecting other than the solvent and acceptor.
Yes. Yes. Already for if you see the Kulkarni also presented their they are moving towards ether, they are getting alpha selectivity.
Yes. So
So
they don't want to put themselves in a situation saying that it is going via one way only. So that may not be very much clear, but it is definitely, that is sure that result is showing the clear result that the moment they are putting this PZ and electron deficient, they are getting the selectivity when other controlling factors are not there, like solvent and nucleophilicity, keeping those things in the minimum side.
yes, basically they are focused on just the protecting group at the C4 and the C6.
Yes. So at this point of time, they are showing just only one factor, how that protecting group is affecting.
Yes, further more control can be done like by
Yes,
using the solvents also.
yes, I think they are already doing it because they are publishing frequently. I have seen lot of papers. So we have to check. I also haven't read, and I didn't read this Boon's paper also. I don't know what is the thing. Because in Boone case, this donor itself is different. So there is also one possibility.
Yes. And the solvent system, I think their
Yeah.
major role of the solvents.
And again, they are
Ethylic
taking
solvents
this
once become, they
dioxin.
will get.
Yeah. And since they are taking dioxin more, so obviously,
Yes.
I think that is also one.
Major role of the solvents here, not the protecting group, I think.
So that's why
In
in
the
this
last,
paper, yeah,
uh,
in this paper writing, they are not saying that Boons is wrong or right. They are just focusing
yes,
on their result, means carefully.
yes.
They are just showing all those controls carefully.
In the last slide where you should freeze sugars of the,
Yes.
in the case of galactose is, I think there is something wrong. Or I'm not getting, like you're telling C4 has the role, right? In the rate. If you see the rate constant.
Yes, if you'll see galactose side, C4 has 3.36 into 10 to the power minus 6. And then if you'll see C6, means C6 is having 9.4. So this hydrolysis set means what? I didn't read it carefully.
I think
So
if you see first you come to glucose, so
we'll
here
come
the
to
C6 has the minimum,
C,
maximum in other way.
C6 hydrolysis is more than the C4. So they are taking just comparison for C6 and C4. So if you'll see C4 rate of hydrolysis
Has
is lesser than the C6.
yes, I'm now come to the galactose.
So in case of galactose C6 is more than C4.
Yes, I think something.
Maybe some, yes, because in writing they are writing that
Yes,
galactose is, and obviously galactose 4 will be hydrolyzed more quickly. We can also think
yes,
of.
yes. I think they have wrote something wrong. Either maybe just
Maybe
vice versa.
power, maybe this thing, maybe.
Yes. If you see this Bruno Linkau presentation, Deepak in the Eurocarb,
Yes,
he
yes,
focused
yes.
with the just floor with the free group. I think this
Yes.
is the only group
Yeah.
he took there also.
Okay, then I have to check. I didn't know that.
I have the like the some
Yes,
similar
that
thing he also took. Bruno
I think
Linkau.
there he was showing hydrogen bonding and all, but I think similar beginning is there. Yes.
Their focus was the more about the interactions, how the functional groups had interaction is depends upon the changing the stereochemistry of the hydroxy group.
Yes, yes. I
Like
think
glucose, mannose, and the galactose, he took all the hydrox and the fluorose. Okay, I'm done.
yes.
Thank you.
I think in paper also again I have seen they have written this C4 is more than C6 in case of galactose, but this value has some problem, I guess.
Yes.
Okay. So we'll move to second part.
Yes.
So instead of showing in slide, I'll show it here itself.